I'm going to explain a little bit about how the difference in medium, going from a transition from one medium to another, can affect the amount of rays reflected, and therefore how refractive index can be used to minimize reflection in things like anti-reflective coatings. So if I put on the reflected ray and then show the correct intensity of the reflected ray, you can see that with this example, going from one refractive index of 1, which would be air or a vacuum, into something at 1.5, which might be glass, you can see that as the angle gets larger, the angle of incidence gets larger, the proportion of the light that gets what's called the weak reflected ray increases. And then as the angle reduces, the angle of incidence reduces, you get more and more transmission. So we're looking at transmission, and you want transmission, as much transmission as possible in things like glasses and lenses, because you want as much light as possible to go through the lens or the glass so you can see clearly. So if we have a very small angle, the smallest possible angle, you can see that going from a refractive index of 1 to a refractive index of 1.5 gives you 4% of the light reflected. So 96% of the light gets transmitted, and if you've got lenses in something like glasses, you'll have a second surface. Then you will have, say, 96% gets transmitted to the second surface, then 4% gets reflected back. Then 4% of that gets reflected back from the other surface, so you do get some back and forth. But generally speaking, there are two strong reflections. There's one from the front surface and one from the back surface, which you could see when I showed you the demonstration using the glasses and the lights in this room. Okay, so if we change this around, we can see we're getting about 4%. But then if we were to go to a smaller refractive index of, let's say, we'll use the example that I used. So if we went to 1.6, we're getting 5.3%. So going straight from n equals 1 to n equals 1.6, we lose 5%. So we're left with only around about 95% getting transmitted. So we're losing a reasonable proportion of the light. Okay, so let's try. What would happen if, instead of going from 1 to 1.6, what would happen if we had a thin coating of n equals 1.3? So we've got n equals 1, n equals 1.3, n equals 1.6. So how much reflection would we have? So if we hit the first surface, so I would change that to 1.3, you can see that you get 1.7% reflection. And then at the second surface, so now this one is 1.3 and this one is 1.6, you get an additional 1.07% reflection. So in total, you're losing about 2.77% of the light. So around about 97% of the light is getting transmitted, which is pretty a fairly simple, clever way of reducing the amount of reflection. There are other things you can do which would require me to go into more detail, like if you have the thickness of the material being around about half the thickness of, half the wavelength of the light, then you'll get some interesting superposition, which means that reflection is even less likely, and that is why you get these different colors on the surface of lenses and glasses.